Curves in Blender offer a lot of flexibility and control that traditional geometry can't match. In this video, I will walk you through every major feature curves have to offer, and I will show you how to integrate them with other tools. I will show you how curves can transform the way you modeling things. Today, I will bring your modeling skill to the next level. Okay, then curves are mathematical shapes used to create smooth lines and surface in 3D space. Instead of meshes created by vertices, edges, and faces, curves are defined by control points, which determine their shapes and direction. To use curves in Blender, you have to press Shift+A and go to the Curves menu. Bezier Curve is defined by control points with handles, allowing you to precise shaping of curves using tangents. A circle adds Bezier circular closed curve, often used as Bevel Profile. A Nurbs curve is defined by control points without handles. It's often used in technical modeling. A Nurbs circle is a closed Nurbs curve shaped like a circle. You can use it similar like Bezier Circle. Path is a Nurbs curve mainly used as a motion path or animation path, often used for camera and object movement. If you have mesh object on scene, you can go to the fur and add fur to your object. Okay, if I add a curve icon will appear in the properties bar. Here we have all curve settings. In the shape bar we can choose is our curve a 3D or 2D object. In 3D we can use all 3 directions, in 2D we can only move from X and Y. The resolution parameter controls how smooth the curve is by determining how much subdivision, how much cuts are generated along the length. We can choose from 1 to 64, but we can also type our own number, like 200. It's also limited to 1024 cuts. If you set up thickness of the curve, the twist method determines how Blender calculates the rotation of the curve cross sections along the length of the curve. Minimum tries to minimize the amount of twisting. Tangent aligns the twist to the curve tangent direction. Z-up keeps the up direction aligned to the global z-axis. We can also smooth all transitions using smooth option. If you are using geometry and bevel option, you can also change fill mode. Back display only the bottom half of the beveled shape. Front displayed only upper part of the shape. Half displayed half part of the shape. And the full display full shape. Curve Deform option is related to Curve Modifier. If we will add a mesh and add Curve Modifier, we can connect it to the curve. Now the curve is connected to this object. Radius takes a radius of the curve. That means that if we scale the radius of the curve, cube also is scaled down or up. We can also use stretch to stretch out the object along the curve, and we can also use bounce clap to fit the length of the curve to length of the cube. Notice that if we have more cuts, the object fits better to the curve. Texture space. In texture space, we can enable auto texture space. That means that automatically adjust the mapping for us. We can also use sliders to change the texture space location. We can also change the size space, and we can match texture space. For most cases, I recommend using auto texture space because we can also change those settings in shader nodes. The most commonly used option in curves is geometry. Extrude is a process of giving the curves a thickness. When we have extrude added, we can also manipulate the offset. Offset is the distance between the actual curve geometry and its control points, indicator. With the taper object, we can control the thickness of the curve along the length. All you need to do is to assign another curve, which will be used to define the thickness variation. Now we can manipulate of its thickness, like this. For the curves that use taper object, taper radius is the option define how the effective curve's radius is computed from the taper object. Override the curve's radius is ignored and the effective radius is equal to the taper radius. Multiply. The effective radius is computed by multiplying the taper radius with curve radius. The add radius, the effective radius, is computed by adding taper radius to the curve radius. Map taper is linked to the start and end mapping option. When start and end mapping is disabled, the start and end factors remove parts of the geometry based on the taper radius. When map taper is enabled, instead of removing geometry, the object is compressed within the specified range. With bevel, we can create a three-dimensional version of a curve. The round option allows us to use a circular profile. Depth control the radius of the profile. Resolution changing the smoothness of the profile. Fill caps simply fill the start and end points. With bevel option, we can always use extrude from geometry option. It allows us to stretch up and down our object. With object option, we can use another curve as custom profile. That gives us a lot of flexibility. Now we can create a complex multi-dimensional shape tailored to our needs. We can also extrude and modify it at any time. Here we can also fill the caps. Notice that when we have selected object setting, we cannot use extrude from geometry. Profile option is great for creating custom symmetrical shapes. By changing this curve, we can do infinite variation. But remember, we have to also change the resolution to see the better result. Notice that we can only create the resolution to 32. Depth option, changing the thickness of the curve. We can manipulate this curve using new points. We can also change its handle type. Sample straight edges adds extra vertices even on straight elements. Sample even lengths distribute the vertices evenly along the profile. In geometry section, start and end mapping is also available. We can change its settings from start and end to determine what part is applied to the curve. Now we learn the most options that curve can offer. At this moment, I would like to move to the most important curve editing features. The most basic thing that we can do on curve is extrude. By pressing E, we can always extrude our curve. By press Alt plus S, we can scale our curve. Using shortcut Ctrl plus T, we can tilt our curve. We can also use proportional editing and change the influence of the tilt. By scrolling, we can change the influence size. The same thing is applied to Alt S. To smooth our curve, we can use Smooth by an Angle modifier. It's especially helpful if we have sharp corners. If we have Bezier Curve, we can press right mouse button and change set handle type. For example, to vector. We can change this handle type and get sharp corners. At any time, we can check the direction of the curve and its normal probabilities. Simply go to the Curve Editing Mode overlay and press Normals. We can also scale those normals, and now we see which direction the curve is going. We can also check the tilt settings and the scale settings. We can also subdivide any curve in edit mode. Depending on which part we want to subdivide, we can select the specified elements, pressing the right mouse button and subdivide on the top of menu. Alternatively, we can also subdivide entire object. Path animation option is outdated. It has retained a few features, but it's still better to use the follow path constraint that have all those options and many more. To use the follow path constraint, add the object you want to move along the curve. Make sure that the starting point of the curve is aligned to the origin of the object you want to animate. Now you can go to the constraint menu and find follow path. Now you have to select the curve that we will be following, and now we can click animate path. Now object is animated along the path. If we select follow curve, the object always following the curve. Also, if we change the tilt, the curve radius scale the object along the curve if we change the scale. Fixed position, freezing the object on start point. The influence show us how much influence the constraint have to the object. Notice that only in path animation settings in curve we can change how many frames animation have. In active spline, C-click close the active spline. The resolution U is the same as resolution preview U. Notice that if we change the one resolution, the second one is also changed. Interpolation changes the way the tilt of the curve segment is calculated. We can use linear, cardinal, B-spline, and ease. We can also do the same thing with radius. Linear tilt is interpolated uniform between control points, creating sharp transition. Cardinal creates a smoother transition by taking the spacing between points into account. Spline generates very smooth transition but ignores the tilt and radius value at individual control points. Ease creates a smooth start and end with a gradual transition similar to animation easing. Smooth simply add the shade smooth. Like most objects in Blender, curves also can be shape key, and shape keys can be animated as well. To use shape keys, we have to add basic shape and add another shape that will be changing the settings. For example, go to the edit mode and change the scale. Now we can change value of this second key. We can also animate by pressing I, changing the position and next I, and now we have animated shape key. If we have animated curve, we can check out the animation tab and see what animation we have added to our curve. Curve is a tool with incredible number of features. A great example of their potential is my Ornament Generator. Not only use all those options, but also add a custom features. That means that you can wrap almost every object with ornaments, including the ones you have created by yourself. If you are interested, check out my Gumroad and Superhive. Over 500 people already trusted the Ornament Generator. To celebrate, everyone who will purchase the Ornament Generator within 2 weeks from start of this video will receive a special discount. Use this code and get 15% off for any version of Ornament Generator add-on. If this tutorial was helpful, let me know in comments. You can also leave a like and subscribe if you want to see more content like this. Thanks for watching and see you soon.